Let's start by discussing physical properties in general and then focus on the physical properties of organic molecules. Evaporation is the change in phase from liquid to gas. Condensation is the change in phase from gas to liquid. Evaporation and condensation are examples of physical processes because intermolecular forces are broken or formed in these processes. And so the substance is not changed into a different substance through the change. Instead, the particles of the substance are simply moved closer or further apart from one another. How easily these changes occur depends on the strength of the intermolecular forces. Intermolecular forces are electrostatic forces that exist between molecules. Electrostatic forces exist between charged particles, and intermolecular forces are forces of electrostatic attraction between opposite charges in molecules. But how is this possible since molecules are neutral? Although a molecule is neutral as a whole, it contains positively charged protons and negatively charged electrons, and these might be unevenly distributed, causing one side of the molecule to be more negative than the other. This polarization is what allows electrostatic forces to be exerted between molecules because closer opposite charges attract one another more strongly than further like charges repel one another. This is what forms the intermolecular bond. The more uneven this distribution of charge in a molecule, the stronger the intermolecular force will be. Some molecules, like water, have a permanently uneven distribution of charge. We call such molecules polar. Other molecules like nitrogen do not have this permanent uneven distribution of charge. We call such molecules nonpolar. Previously, we studied the factors which affect whether a molecule of a particular type is polar or nonpolar. We looked at the influence of electronegativity difference and molecule shape. The intermolecular force between two polar molecules is called a dipole-dipole intermolecular force. A subset of this is the hydrogen bond, which is a particularly strong dipole-dipole force. Hydrogen bonds occur between molecules which have hydrogen bonded covalently to a small, highly electronegative atom, such as oxygen. Since water consists of hydrogen bonded covalently to oxygen, water molecules are held together by hydrogen bonds. A polar molecule can induce a dipole in a nonpolar molecule. The negative end of the polar molecule, for example, repels electrons in the nonpolar molecule to the side further away from it, creating slight positive and negative ends, as shown here. These dipole-induced dipole intermolecular forces are weaker than dipole-dipole forces, but stronger than momentary dipole forces. Momentary dipole forces are also called London or van der Waals forces. They exist between nonpolar molecules. Due to random motion of the electrons, one of these nonpolar molecules might have a slight dipole at any one moment because more of its electrons happen to be on one side of the molecule than the other. This induces a dipole in an adjacent molecule. London forces are very weak. As we've already discussed, during evaporation, the intermolecular forces between particles in the liquid phase are broken, changing the particles into the gaseous phase. Only particles with sufficient kinetic energy are able to move quickly enough to break the intermolecular forces which hold them to other molecules. Temperature is a measure of average kinetic energy. Even at very cold temperatures, there are at least a few particles which have sufficient kinetic energy to allow evaporation at the surface of the liquid. Once these particles have changed into a gas, also called a vapor, they exert a pressure which is called vapor pressure. Evaporation happens at all temperatures at the surface of the liquid, but at a certain temperature, evaporation happens within the liquid, causing large bubbles of vapor to rise and explode at the surface. We call this boiling. What's going on during boiling, and why does it only happen at one particular temperature, called the boiling point, for a certain pressure? At any temperature, some of the faster-moving particles within the body of the liquid will try to break their intermolecular bonds and so vaporize. However, at temperatures below boiling point, there are not many particles with enough kinetic energy to be able to do this, and so the vapor pressure that they exert in a little bubble that they form is so weak that atmospheric pressure squashes the bubble before it can even form, forcing the particles back into the liquid phase. As temperature is increased, a greater proportion of particles have enough kinetic energy to be able to break the intermolecular bonds, keeping them in the liquid phase. Therefore, the vapor pressure that they can exert increases. When the vapor pressure they exert equals atmospheric pressure can no longer squash a bubble of vapor formed inside the liquid. So the bubble can form, and that is when boiling happens. So boiling happens when the vapor pressure of a substance equals the atmospheric pressure exerted on the substance. And that happens at a certain temperature, which is called the boiling point. The vapor pressure that a substance exerts and the temperature at which boiling occurs depends on the strength of the intermolecular bonds. So in other words, the strength of the intermolecular forces determines how much energy you have to add to the substance for those particles to have enough kinetic energy so that they will break their intermolecular forces. Let's now compare two substances. We've got polar water, which has the relatively strong hydrogen bonds between its molecules, and we've got non-polar nitrogen, N2, which has very weak London forces between its molecules. Now, how do these two compare? How do they compare in intermolecular force strength, in the energy needed to break the intermolecular forces to cause evaporation to occur? How do they compare in their boiling point and in the vapor pressure that they exert at a particular temperature? To help you in this comparison, you should choose one of the words in red for each of the lines to describe water compared to nitrogen. Pause until you have done that yourself. Water has stronger intermolecular forces due to the greater polarity of the molecules compared to nitrogen. Therefore, more energy is needed to break water's intermolecular forces. Since more energy is needed to break water's intermolecular forces, water needs to be heated up more than nitrogen before it will boil. So water has a higher boiling point than nitrogen. The reason this is so is that at a particular temperature, fewer water molecules will be in vapor form than nitrogen molecules will be. That's because it's more difficult to get the water molecules to vaporize because they're held more tightly together. So, since fewer water molecules will be in the vapor form at a certain temperature, water's vapor pressure is lower than nitrogen's at a particular temperature. Therefore, to raise water's vapor pressure until it equals atmospheric pressure will take more heating, which is why boiling point is higher for water than for nitrogen.